the latest version 3.1 of Python, and the rest are the inbuilt libraries in Python. First we have the PySerial, which was used to establish the hardware communication between the accelerometer and my computer. Next is the Matplotlib, which is used to create visualization, and Pandas and NumPy to perform data analysis, and at last is the Tkinter, which is used to create the graphical user interface. So now we have a comparison of some of the key features between the traditional systems of aerosol monitoring and my Python solution, and the advantages which my solution has. So first we have the real-time data. So the traditional systems give delayed batch processing, whereas my Python solution gives timely updates after every minute, giving faster response. The traditional systems often come with a lot of cost. So my solution, being open source, reduces the cost by 80%. So the traditional systems are often limited by the vendor, and my solution, being open source, is fully programmable and can be tailored to any need. So the user interface of the traditional systems is always very complex, whereas I have created an interactive graphical user interface which is user friendly, and there is no training needed to learn to use the software. So also the traditional systems give incomplete data analysis, which was discussed in the earlier slides, and my Python solution provides hourly and daily statistics, so we can get actionable insights. So now moving on to the results of the software. Here we have the home page of the login system of this aerosol monitoring software. Here we have the user access and the admin access. After clicking on either of the two buttons, we can proceed with logging into the system, or if we are a new user, we can register for the software, and also there is the functionality to change the password if we have forgotten our password. So there is unique access for both the admin and the user. So this is the live plot tab, and there is the functionality for threshold alerts, which is specific only to the admin. So here we can select one wavelength out of all the 7 wavelengths using the drop down list, enter the value of the threshold here, and after clicking this button it will display the wavelength and its value. So whenever the value of the threshold wavelength is exceeded, we can see a real time black carbon concentration. The screen becomes red, we get a threshold alert along with a beep sound. So next we have the daily plot tab. So this tab is common for both the user and the admin. Here we can select any date from the drop down list and view its daily plot. So just like the daily plot tab, we have the hourly plot tab, and here the hourly plot tab is specific only to the admin. We can select the date and the 1 hour range of that day and see the hourly plot of that specific time range. Next we have the aerosol properties tab, which is also specific only to the admin. So these are the properties which are derived only from the value of black carbon concentration at 7 different wavelengths. So this is the raw data tab, which is also specific only to the admin. So the data which is collected from the accelerometer is stored in a folder in the form of text files. So those text files have been accessed and populated in the drop down list. So this text files gives the data of 7 different wavelengths. Along with that, whenever these hourly statistics and daily statistics are calculated, it will display in the same text file. So next we have the daily statistics tab. So the daily statistics tab gives the statistics such as mean, minimum, maximum and standard deviation of the black carbon concentration at all the 7 wavelengths. So just like the daily statistics, we also have the hourly statistics tab, which provides the statistics of any particular 1 hour range of any particular day. So this software is not just theoretical, but it's already paving the way for several real-world applications such as smart city air quality networks, industrial compliance monitoring, climate research stations, public health early warning, and agricultural optimization. So there is a lot of scope for upscaling this project, and this project can be expanded in the following ways. So the first is enhancing data collection with the help of use of more and more sensor technology, expanding data processing capabilities with the use of cloud computing, and improving data visualization by creating even more interactive plots and dashboards, integrating advanced analytics to get anomaly detection and even more analysis. And the last point is very important, which is the data encryption and data security. So proceeding to the conclusion, I would like to highlight a few key achievements of this project, which was the delivery of a real-time Python monitoring system with less than 500 millisecond data latency and 7 wavelength analysis along with threshold alert. So it's very cost effective and has reduced the cost by 80%. It has enabled new scientific capabilities with the help of threshold alert, which helps instant pollution event detection and long-term climate trend analysis. So these achievements have a great impact on environment and technology. So I would like to conclude by expressing my gratitude towards Physical Research Laboratory for providing me this opportunity to work as an intern on this project. Thank you.
The forum is open for any questions.
Do you want the Q&A session also to be recorded?
No.